Hello ma'am, I am Mohammad Riyasuddin, roll number 20955 A0408 from ECE B section. In this lecture, I am going to explain half adder using behavioral modeling. Coming to VHDL programming, we can write any program in three different ways. That is, we have behavioral model, data flow model, and structural model. Behavioral model is nothing but by using truth table we can build a program in behavioral model. If we use equation like A and B, A or B is nothing but data flow model. Coming to structural model, by using the gates. In this topic we are going to see half adder using behavioral modeling. This is nothing but half adder. If you give two inputs, we'll get the outputs as sum and carry. This is a circuit diagram. Here A and B are connected to AND and XOR gates. From the AND gate we are having carry output. From XOR gate we are having sum output. Carry is nothing but AND gate means AND gate output as A into B, and some XOR gate output we know that A XOR B, that is A into B complement plus A complement B. Coming to the truth table, the half adder truth table is following as: when you give both low inputs, the sum is 0 and carry also 0. When you give any one single input as high, we'll obtain sum as high. If you give two high inputs, we'll obtain sum as 0 and carry as 1. Please remember the truth table for easy understanding, because we are going to do the programming in a behavioral modeling, which is nothing but by using truth table. Here, coming to VHDL programming, library IEEE, use IEEE dot standard logic 1164 dot all. These library IEEE and this standard logic is nothing but which are used to obtain output in the software. And here entity, for every VHDL program there are two different blocks as entity and architectural. In entity block we have to define all the inputs and output ports, and in the architecture behavioral we are using the process. Coming to entity half adder is port of A, B in standard logic is nothing but A, B are inputs, sum and carry are carry out as outstanding logic is nothing but outputs, and half adder. Coming to the architecture behavior of half adder is begin. Half adder is nothing but process of A, B is inputs are processing as begin. If using if else condition, coming to if A equal to 1, then sum is less than equal to, it means sum assigned to not B. If A equal to 1, sum assigned as not B. See, once observe truth table, if A as 1, sum as not B, same as B is 0, not B as 1, B as 1, not B as 0. Coming to the carry out is assigned as when A is equal to 1, carry out as B. So see here, same, when A is 1, carry out as same B. When B is here, B is 0, carry is 0, B is 1 and carry is also 1. And then else, in else, if A equal to 1, then else sum is B, and carry out as 0. It means when A is 0, sum as same B 0 0 1 1, and here carry out as 0 0. Carry out as 0, it means when A is 0, carry is also 0. This is nothing but the process. And if else is end if, by using end if else is stopped, termination, and end process, half adder, end behavior. This is nothing but program. Coming to the simulation mode, the simulation output will obtain simulation output as like this. See, when A is 0, B is 0, sum 0 and carry also 0. When A is 0 and B is 1, we'll get sum as 1 and carry as 0. When A is 1 and B is 0, sum as 1 and carry as 0. It is nothing but when the inputs are, when both inputs are low, output also, sum and carry also low. When inputs as any one input is high, in output the sum is high and carry is 0. When both inputs are high, sum as low and carry as high value.